Okay, so let's just talk that through. We left the coefficient 4 out in front. The antiderivative of sine is negative cos. Plus, leave the coefficient 2 out in front. The antiderivative of x to the 4th. Add 1 to the exponent, divide by the exponent. Minus x to the negative 1/2. So your power rule again, leave the negative out in front. And add 1 to the exponent, divide by the exponent. And when we're dividing by 1/2, it's the same as multiplying by 2. Okay, we're going to add one more concept to this. Find f, the original function, if this is the antiderivative, and we know that when x was 0, y was negative 2. We have a point on our initial graph. When this happens, these are called your initial conditions. I guess technically initial conditions means you put a 0 in for your x value, and this is your starting point. You don't always get a 0. You could get any point on the graph. When this happens, it means you can solve for c. Okay, so here's the derivative. What was the original function? Well, the most general solution is the antiderivative of e to the x is e to the x plus 20 times the antiderivative of 1 plus x squared to the minus 1. Do we remember what this would be? 1 over 1 plus x squared. Tan. Awesome. So the derivative of tan x, not tan x, inverse tan, right? Inverse tan is 1 over 1 plus x squared. So the antiderivative of 1 over 1 plus x squared is arctan x, or we'll just write it tan inverse x, and plus a constant. So check my work. Take the derivative of e to the x, I get e to the x. Take the derivative of 20 arctan x, and I get 20 over 1 plus x squared. Take the derivative of a constant, I get 0. How do I know what the constant is? I put in my initial conditions. That is, f at x is equal to negative 2 when x is equal to 0. Or negative 2 is equal to e to the 0, which is 1, plus 20 times the angle that has a tangent of 0. What angle has a tangent of 0? Where's tangent 0? Remember, tangent measures the slope of your angle? You're showing me. Say what it is. And remember, arctan is defined between negative pi by 2 and positive pi by 2, so that would be at the angle 0. So I get negative 2 is equal to 1 plus 20 times 0 plus c, or negative 3 is equal to c. So we were supposed to find f under these conditions, so here's my solution. F at x is equal to e to the x plus 20 arctan x minus 3, filling in those initial conditions. Okay, just like you can take the derivative many, many times, you can take the integral as many times as you want to. So I can take the first derivative, second derivative, third derivative, etc. I could integrate and then integrate my integral and then integrate and integrate and integrate that. Okay, so here I'm given the second derivative, and I'm asked to find the original function. Well, you're going to have to work backwards in steps. Given the second derivative, work backwards once and find the first derivative. Do it again and find the second derivative. Okay, so we've got f double prime, and then we're going to come back and look at these initial conditions and solve for our constants. So if f double prime is 12x squared plus 6x minus 4, what's f prime? I'll give you a moment to write down the answer. We all got that? Some of you are doing this intermediate step, and some of you are going from here to here. Both are fine. Just depends on how quickly you just do the calculation in your head and how confident you feel about that. Okay, and then I need the original function, so I need to do this again. The antiderivative of 4x cubed plus 3x squared minus 4x plus c. Let's do this one together. Add 1 to the exponent, divide by the exponent. I'm going to get x to the 4th. Plus, add 1 to the exponent, divide by the exponent. X cubed. Minus, add 1 to the exponent, it becomes 2, divide by the exponent. Minus 2x squared. What's the antiderivative of a constant? C times x, yes. And then I need another constant, don't I? Use a different letter or you'll get these two mixed up. Okay, so just a little note. Use a different letter because these are different constants. Okay, so there's f at x. Let's go back to our initial condition. The function at 0 is equal to 4. So the function at 0, if x is 0, y is 4. 0 to the 4th plus 0 cubed minus 2 times 0 squared plus c times 0 plus d, which tells me that 4 is equal to d. So then I know this much. So it's like solving a puzzle working backwards. Let's put in the piece we just found. F at x is x to the 4th plus x cubed minus 2x, x to the 4th plus x cubed minus 2x squared plus cx plus 4. We use this information. Now let's try this information. The function at 1 is 1. So y is 1 when x is 1. So 1 is equal to 1 to the 4th plus 1 cubed minus 2 times 1 squared plus c times 1 plus 4. So I've got 1 is equal to 1 plus 1, 2, minus 2, plus c plus 4. Subtract 4 from both sides, find c. Here we're asked to find f at x given these conditions. So what is f at x under those conditions? Well, f at x would be x to the 4th plus x cubed minus 2x squared plus, minus 3x plus 4, filling in for our c and d.